Hi everyone, in this lecture we are going to customize and export our plots. The code that you see on the screen belongs to our previous lecture because we want to build on top of this code. Now, again, I just want to go over this RC params one more time. The reason that we provided RC params was this first key. This is going to refer to just making our plot fit nicely. All right, so everything that we have on our plot, it is going to fit nicely there. And the axis, the title pad, it is going to provide some padding for our titles, so the title of the plot will not overlap with the plot itself. Now, talking about RC params, I'm just going to provide another index for our RC params. I'm going to say plt.rc params. And then I'm just going to provide the figure. So this is going to be the figure dot fig size. The reason that I'm providing this for the RC params is because what I'm trying to do is just making this plot bigger, right? So the fig size, I wanted to set it to 20 and 10. Let's save that. Let's run that and let's run this one. So this is the result. I'm going to zoom out. I know that you are not able to read these numbers. They're very zoomed out. I'm going to zoom out even more. This is 100%. This is the normal flow. But now right here, what I'm going to do is from now on, we're going to work on modifying this plot. So right beneath here, first, let's go ahead and let's add a label for the y-axis and modify the existing label for the x-axis. This acquisition year. So how can we add a label? We have this subplot dot set underscore x label. So this is going to grab the x label. And we can set it to what do you want the text to be. So we want the text for the X label to be the acquisition year. Acquisition year. Now you can see this is better. If I zoom in, this says acquisition year. It's exactly the name of the column, but I don't want it to be that. I guess I could zoom in just to show you our plot. So this is acquisition year, and this should be subplot. I'm going to copy this, put it down here, and I'm going to say set Y label. And what do we want the Y label to be? I'm going to say artworks acquired. So artworks acquired. Let's save that. And if I come in here, you can see it says acquisition year and it says artworks acquired. Perfect. Let's go to 100%. Let's go ahead and let's rotate the X values by 45 degrees. And what I'm going to do is I'm going to grab, these are very large numbers for the y-axis. I told you that we are going to change the representation. I'm going to represent them in the form of logs of 10. So beneath here, I'm going to add the rest of our code. So what I'm going to do first is, let's go ahead. So here we have an axis equal to subplot. We could add a ROT equal to 45 degrees. And if I run this, you can see that these are rotated by 45 degrees, the X ticks. I could add another keyword argument, and that is going to be log Y is equal to true. If I run that, okay, let's zoom in. You can see that it is 10 to the power of something. It is not showing that for some reason. We're going to enlarge their text as well, so don't really worry about it. Let's control the behavior of our tick locators. For that, we have a locator params function. So it is based on the subplot. So it is locator underscore params. Now by default, the number of bins is 10 for any matplotlib plot, and that is the number of times it has been, the number of sections for a specific part of a tick. It's 10. We can change that to, let's say, 50, and in that case it is going to give us years in the addition of 5. So we are going to go to for now it is like 1825, 1850. can I make sure you can really see that? So if I zoom this in, so you can see it says 1825, 1850, 1875. If I add that n bins equal to 50, what it is going to do is it's just going to provide that separator, or that it is going to increase the granularity to granularity by decreasing the year from 25 to just 5. Which axis do we want this to be applied on? It is the x-axis. So I'm going to have to specify the axis as well. So let's run that. It says subprogram's going to use a keyword n. It is n bins, number of bins. Just run it again, and there we go. So if I open this in a new tab, and now if you take a look at it, it says 1850, 20, 25, 30, 35, 40, 45. Now you can see we have that gigantic peak that we have. All the values going up until that peak, they are way better visible. We're going to work with this even more in this lecture. So what it is that we want to do, let's provide some font families for our labels and our text. We are also going to increase the font size of the X and Y labels. We are going to increase the font size of the X and Y text, add a title. We are also going to add a grid by the end of this lecture as well. So how can we do all of that? So here on the top, before that figure, what I'm going to do is I'm going to create a title font, and I'm going to set it equal to a dictionary. Okay, you know what? I'm just going to copy these two. They're very, very time consuming to type. So we have this family, which is Source Sans Pro. The color is dark blue. This is for the title. The title that we have yet to create. We are going to add the title. Don't worry about it. This is the weight, font weight, and this is the font size. And you know all of these styles from CSS. I don't really have to explain anything to you. Now, how can we add the grid? We are going to add another argument, and that is going to be grid. Let's set it to, true. Okay, let's go ahead and let's actually use the fonts. So in here, after the acquisition here, what I'm going to do is I'm going to say font dictionary. This is going to be the labels font dictionary. So this belongs to the labels. I'm going to add the same thing for the Y label as well. So let's just add that in here. Font dict, it is going to be labels font. And then what is going to be the label padding? So I'm going to say label pad. Let's just set it to 10. These are very much arbitrary values. You can change it anytime you want. Let's add a title for our plot as well. So I'm going to say subplot. All of these functions are available on the subplot. Let's say set title. And what is the title? This is going to be the Tate Gallery acquisitions. Perfect. And what is going to be the font family? It is going to be the font dict equal to title font. So the title font, it has been used for the title, and the label fonts, they have been used for the labels. Let's actually save this and run all of these changes. So now what do we see? We see the acquisition year more clearly. So if I zoom in, we see the artworks required. We also have a Tate Gallery acquisition. You can see the spacing from the bottom of this text to the left side of these numbers, these 10 powers of 10. This is the padding that we have. So if you increase the padding, this is going to be increased. So if you put it to 100, it is going to be better visible. Okay. Okay. Oh, oops. This is for the X. I just changed for the X. So for the X, it's the top of the text from the bottom of the numbers or the X text that we have. So it really depends on your choice. What do you want to? How do you want to go about it? Let's increase the font size for the text as well. Very, very small. So I'm going to say plt.x text for the text which appear on the x-axis. And I'm going to say font size. Let's set it to 16 for the x. And I'm going to do the same thing for the y text as well. So this is the y text, but the font, I'm just going to change it to 18. Let's run that. There we go. Now you can see that better. So even if I zoom out, you're able to see it. So it is powers of 10. And then we have all of our years. So this plot looks way better than the plot that we have here. You can see that this plot, this is much more readable. The granularity for the X text, it has been increased. We do have actual title and actual labels that refers to our data. We have our peak, but the peak doesn't make any other part of our data any less insignificant. So I think with this, our lecture comes to an end. And at the end of this, our customization of the plot comes to an end. But what I want to do at the end of this lecture is show you how you can export your plots. And I'm going to show you in two ways how you can export that. One is going to be the .png file, which is like a JPEG file. The second one is an image file. And the second one is an SVG, which is short for Scalable Vector Graphics. The difference between SVGs and PNGs or JPEGs is that SVG is not like zoom dependent. It's not aspect ratio dependent. So it doesn't matter how long, how far you actually zoom into that SVG. It's never going to lose its it's never going to lose its focus or its quality. That's why it says Scalable Vector Graphics. So you can zoom as much as you want, but you will never be able to see the pixels for that image. First, let's save a file to a PNG. So I'm going to say fig. Keep in mind, this is our master object in the Matplotlib, and this is the function save fig. What do you want the name to be? So here you provide the path, the name for the file, also the extension for the file. I'm going to call it plot1.png within the same directory. And if I run this, if I come in here, you can see we have that plot1. It is of type PNG file. Let's just double click on it and take a look at it. Here is our chart. It is very, very cool looking. But the thing about PNG is if you keep zooming in, at some point you can see that we lose our quality. But as far as SVGs are concerned, this is not going to happen. So you basically have to do the same thing. I'm going to do plot2 instead of .png, I'm going to say SVG. Let's run that. There we go. And SVGs usually we open them with browsers. So I could open it with Microsoft Edge. Just double click on it. And there we go. This is our SVG. So you can see it has a very, very much better quality and pixel ratio. So it doesn't matter how much you zoom in. It's always going to be like the highest quality. This is the good thing about SVGs. SVGs are very lightweight and they're very performant when it comes to actually using them in your websites. So an SVG file is going to perform way better, is going to load way faster than, let's say, a JPEG file or a PNG file in this case that we have. And you can see with the same plot, it is 3 kilobytes lighter than the PNG file that we have. It is almost 3 kilobytes lighter than that. With this, our entire lecture of customizing and exporting our plots comes to an end. This is going to wrap up the entire Pandas for Data Science Essentials course as well. We have had a lot of fun working with Pandas, a lot of data analysis, a lot of data manipulation. And these are the starting points of data science. So if you want to become a data scientist, this is going to pave the path for you to actually get started in one of the hottest and highest in demand and one of the highest paying jobs of ever, which is data science. You can get into that using this course. This is going to just pave the way for you. Of course, there is like a ton of more stuff that you have to learn if you want to become a data scientist, but these are the fundamentals. If you get these right, all of the rest of the stuff, they're going to be easier to learn. The next course is going to be the NumPy for Data Science Essentials course. We use NumPy to do computations, mainly on arrays. Well, generally on arrays and matrices. So if you have some high school matrices knowledge, that's good, but if you don't have it, that's cool as well. We're not actually dive too much into the math of it. We're just going to work with the computations, because what NumPy allows us to do is it is going to abstract away all of that complicated math. But don't get me wrong, if you want to become a data scientist, if you want to work in any field that it relates data science, or that requires you working with some kind of data in some form or another, you need to be really good in math. So if you're like very math centric, this is going to be very good for you and you're going to enjoy that. But even if you're not math centric, then you need to have like a very strong background and a very strong knowledge in mathematics if you want to become a data scientist. Of course, it's science, right? Data science, so you need to know mathematics. There is no way around it. But as far as our courses are concerned, essentials courses, you don't really have to know anything. Like you have to have heard of like what a matrix is. And we have also worked with NumPy before, so that's going to be like a good background knowledge for you. Go ahead, just check that lecture that we work with NumPy, and then dive back into that NumPy Essentials course, which comes right after this one. So see you then.